and welcome to the episode number 8 of the Google Cloud Platform podcast. I'm Francesc and Mark, and I'm here with my co-host, Mark Mandel. Hey, Mark, how are you doing?
I'm good, thanks. How you doing, Francesc?
Pretty good. Back to San Francisco and enjoying the awesome weather.
Yeah, I'm back in San Francisco too. It's a little bit warmer than where I've been previously, so pretty happy about that.
I remember you were in Vancouver, so yeah, I can imagine. So we have a very interesting episode coming today. We're going to be interviewing one of our dear teammates.
Yes, Felipe
Hoffa. He's a developer advocate for the Google Cloud Platform, like both of us, but he specializes in big data.
Yeah, he does some really interesting stuff with big data.
So we're going to be talking about big data. What is big data? Why is it cool? What can you do with it? What can you do regarding big data on Google Cloud Platform?
Big data, so hot right now.
Yeah. I think it can be really interesting, and we're going to try to discuss as much as possible. But again, if people have extra questions, we're always interested on those.
Definitely. If people want to get in contact with us, let's hit them up right now.
Let's go with that. So if I remember correctly, it's on Twitter, it's at GCPPodcast.
Yep.
On Reddit, we have a subreddit, r/GCPPodcast.
Yep. There's a theme here.
We have a webpage. It's gcppodcast.com. We have an email, hello@gcppodcast.com. And you can find us on Google Plus as GCP Podcast.
Yeah, it's plus GCP
plus
Podcast.
GCP Podcast. There you go.
There we go.
Easy.
Wonderful. So yes, if you have any questions or anything else you want to send to us, please do. We love to get the comments and the feedback.
Yeah. Cool. So before we start with the interview to our dear colleague, Felipe, let's talk about the cool thing of the week.
We have a very cool thing of the week, although we're a little biased, of course. It's that we took a pretty cool product, but we decided just to make it better.
I know the joke. It doesn't really work with your accent, though.
It doesn't work with my accent. So currently in beta, is better. Oh, God, I've just ruined it.
Yeah.
But yeah, we have version 2 of our Cloud SQL product. Do we want to talk a little bit about what Cloud SQL is?
Sure. So Cloud SQL is basically just MySQL on the cloud.
Yeah,
that's
really
pretty much what it is. It has some really cool features, like the fact that you don't need to care about that instance working. That's on us. So you basically say, hey, I need one instance running. And if there's any patches or security or whatever needs to be done, it's Google engineers will do that for you.
Yeah, and if you want to replicate it and do that stuff like that, it's sort of just push button. It's just really easy.
Yeah, so everything is basically it's like a self-driving MySQL instance on the cloud. I like to say.
Nice.
And now we have version 2, which is in beta and better. You see, with my accent.
Yeah, with your accent that works. Yeah, totally.
So what's new with the beta version?
So basically, it is just better. So it's a lot faster. It's I have a number here. It was I believe up to 7 times faster than the current version, which is pretty good. And you don't really have to do very much above and beyond that. And also it scales out a whole lot better. Up to 20 times the storage capacity of first generation.
Yeah, I actually saw there's a graphic. We'll put that in the show notes too. But there's a graphic where it shows how much it scales. And when you have enough traffic where having 64 cores helps, you're gonna see that it scales. It's much faster. It's able to have a way higher transaction per second count than V1. There's also storage. It used to be 500 gigabytes. Which is decent.
That's all right.
Now it's 10 terabytes.
That's pretty decent.
Which is pretty decent too. That's a decent amount of data indeed. So that's pretty much it. It's still beta, so it's not all the features are still not there.
Yep.
But we're working on them.
Yep.
So if you're interested on MySQL and on the cloud, just give it a try and let us know how it goes.
Yeah, it's pretty straightforward. When you go to create your instance, just choose second generation and away you go.
Awesome. Great. So let's go with our interview.
Let's talk to Felipe.
So we're here with our colleague, Felipe. Hi, Felipe.
Hello, Francesc. Hello, Mark.
So this is Felipe Hoffa. Tell us a little bit about yourself, Felipe. Who are you? What do you do?
My name is Felipe Hoffa. I'm a cloud developer advocate.
Yep.
Cool.
I talk a lot about big data, especially Bigquery. I started at Google almost 5 years ago. 5 years ago, I was interviewing at this stage. I started as a software engineer.
Nice. Like me, actually.
Not
Yeah.
like me.
Not like you, but yes, we have a similar story. And then 2 years later, I joined the developer relations team.
Nice.
And I became a software engineer with a license to speak.
With a license to
I
speak.
like that.
That's pretty badass.
I'm going to use that. I'm going to use that. I like it a lot.
I said it first.
Great. So you said that you talk a lot about big data. So we're going to ask you just to do that. Tell us, what is big data for you, at least?
What is big data?
Yeah.
Yeah.
Yeah, a lot of people have tried to define what is big data.
Yeah. So what's your definition?
What is the definition? Like
Actually, yeah, what is the
absolute definition?
Okay, we are at Google. We are at Google. You know how we call big data at Google?
Data.
Exactly.
I knew that one.
We call it data. It being big is a very weird concept. Data has no size or weight. Some people call big data problems that are complicated. Or, for example, I love asking people when I go to a conference, who here works in big data? Normally, people have no idea if they do.
Okay.
But then I ask them questions like, who knows SQL? People that know SQL are people that are working with data, with databases.
Fair enough.
Then my next question is, who has had queries that run for more than an hour, for a day, or that simply don't run?
Okay. I can see. Yeah.
Okay.
And that's when we enter a different domain where problems are taking a long time, where problems are complex to solve, at least with the technologies they know.
Okay.
Okay. So rather than look at it from like, this is how much like terabytes or petabytes or millions of rows, rather look at it from the perspective of, I've got a problem, I need to solve it when it has to do with data, but it's going to take me 3 hours a day, a week, given the tools that I have at my disposal.
Exactly.
Okay.
That's when people think, oh, this is a big data problem.
Yeah.
Then we have the Google way of solving problems,
Yep.
where we bring the same problem here with technologies we have created, developed here, and the same problem that might take you days using your standard toolkit might take you 3 seconds.
Right.
Nice. So big data, finally, it's not really about the size of the data. It's really about how much time it takes you to solve a problem and how like standard techniques at some point, they just don't work anymore, right?
Yeah.
So what kind of techniques do you use then?
More than techniques at this time, it's about what tools.
Okay.
For a while, to be able to manage terabytes of data, billions of rows, people had to learn new technologies. We have, for example, MapReduce, Hadoop, Spark, Pig, etc. But then there is a lot of complexity there. You need to wrap your mind around using parallel servers, developing parallel algorithms. But sometimes you just want to count things. You just want to know what are your top customers or how things are changing. So instead of going through all these technologies, today you can use technology like Bigquery, where you just load your data, ask your questions with SQL, and you get the answer in seconds without having to learn a whole new mindset.
Okay. So you mentioned that that one of the things that we do at Google is we have internal problems, we solve them, and then we put them as available to anyone else outside. Is BigQuery one of those?
Yeah, well, historically we've been publishing all of these papers, the MapReduce paper, the et cetera, et cetera, et cetera. We've been through that, yes. And one of those papers is Dremel. How do we process terabytes of data using SQL at scale?
Yep.
And that paper explains the whole detail of how do we parallelize this task without making it.
Okay, we'll put that in the show notes. Yeah, that's really interesting.
So yeah, historically we released the papers and the world rushes to implement them with open source implementations. But now we have Google Cloud. Now we make these services, the same services we use internally, available for everyone.
Okay.
And that's what we're doing with Bigquery. That's the service that implements the Dremel paper.
That's something I actually heard a story about Dremel. I don't know if it's true or if it's just like a legend. But I heard about the fact that when Dremel was created at Google, to process 24 hours of logs was taking almost 24 hours of logs, which means that like if processing 1 hour of logs takes more than 1 hour, then at some point you're gonna lose logs. Like is that true? Like good Dremel solves that problem? Like all of a sudden, instead of hours, you go down to minutes or seconds?
Yes. I have no idea if that is true.
I heard it. I don't know.
I know it's true for many customers. I know people that are working with huge data sets that were only able to process a small percentage of the logs and through processes that run all night and fail during the night. And suddenly they try BigQuery and, it takes 5 seconds and no babysitting of processes or anything.
So BigQuery really is like an example of what you were talking about before, people struggling up against walls of how much time like processing was going to take and suddenly going from hours, days, weeks down to seconds.
Yes.
Yeah.
And without involving any special knowledge.
It's just SQL. And
just
that's
SQL.
it.
Yes.
Yeah,
we are just talking about data.
Wow.
You have data and you have questions.
Yep.
That's it.
So how do you put that data in BigQuery?
There are two main ways. One is batched. If you have a CSV or JSON files, you can load them into Google Cloud Storage if they are big enough. So it's good to go through Google Cloud Storage when you have very big files. You store them there, and BigQuery can easily ingest files from these places.
Cool.
Or also BigQuery can ingest streaming data. So if you have any stream of real-time data coming, you can load up to 100,000 rows per second into one BigQuery table.
That sounds a lot like what we were discussing last episode about messaging. We're talking about Cloud PubSub.
Yeah.
Is that the way to stream data into BigQuery?
That's one way. Now, Cloud PubSub doesn't output data straight into BigQuery.
Okay.
Don't ask me why, but maybe one day.
Lovely.
But
We'll fix that.
But one of our customers wrote a very nice blog post where they use PubSub to ingest a lot of streaming data, and the final output goes into BigQuery.
Yep.
Now, in the middle, they use Dataflow.
Oh, interesting.
Yes, Google Cloud Dataflow.
Actually, since we're already discussing about Cloud Dataflow, so BigQuery is one of the products that you can do big data processing with Google Cloud Platform. What about Cloud Dataflow? What is the difference, and why could you use one or the other?
Yeah, so if you have data and you have questions that you can express with SQL, BigQuery is the place.
Okay,
cool.
Now, with Dataflow, we are able to solve different kinds of problems, like where you would use Java code to write more complicated stages.
So is it more like MapReduce or?
Yeah, Dataflow is the new MapReduce. We published the MapReduce paper like 10 years ago.
Yeah, maybe more. Actually.
It's a while ago.
Yeah.
Yeah. And since then, we published two very interesting papers. One is Flume Java.
Yeah.
And that talks about how we orchestrate these pipelines of MapReduces and optimize them on the way. And also the Millwheel paper that deals with streaming data. And Dataflow is it's a service that encapsulates these two ideas.
Okay.
How do we write a smart pipeline of MapReduce processes? So MapReduce has this problem that if you really want your MapReduce processes to go fast, you have to do a lot of manual optimization.
Okay.
And Dataflow takes care of that, and you just write your pipelines as you would write them mentally, and then the optimization is part of the process. You don't have to care about optimizing things manually.
So what sort of things would I be using Dataflow for? Like, if I can get my data into BigQuery and process it there, like, can you give me an example of, like, is it, like, real time, or is it, like, what sort of stuff am I doing with Dataflow?
Yeah, so Dataflow has two, as I was saying, two modes.
Yeah.
One is the budget mode,
Okay.
and the
What
other
is
one
that?
is the streaming mode.
So what's the difference?
Well, just to before I answer, what's the difference? Part of the charm of Dataflow is that your same code could work for both types of data.
Okay.
Usually people have to deal with one system for batch processing and one system for streaming processes. With Dataflow, you can do both. Just to give you a simple example of what I've used Dataflow for, when I found some weblogs that were in binary format that I wanted to load into BigQuery, I needed to write some code. The logs were massive. It was billions of rows, so I had to process them in parallel. So I could write just a simple script in Java inside Dataflow, and Dataflow took care of doing this process, splitting it, and running it into many different servers.
Okay. So you're using it to sort of do data transformations. But just massive data transformations, though.
Exactly.
Yeah.
Dataflow takes care of the parallelization
Nice.
and making this process smarter. But what's really brilliant about Dataflow 2 is how it treats streaming data.
Yeah.
So I mentioned that you can stream data into BigQuery and you can analyze it later, immediately with queries. But sometimes you want to run some online algorithms. I love the Wikipedia example where you can look at the change log. So what pages are people changing at any given time? And the question there is, from a stream of, like if you have a list of what pages are changing in Wikipedia at any time, how can you find what are relevant news?
Interesting.
Yes. So how can you tell this change is important versus this change is not?
Yeah.
So you could do something quite similar, like trending topics on Twitter and stuff like that. That's really interesting.
That makes sense.
Yeah. So there's a Googler, Thomas Steiner, that wrote a paper on this. And he looks at three things. Is this page, how many changes this page has had in the last minute?
Yep.
How many different people are changing it?
Okay.
And there was a third factor that so it's how many changes, how many people, and how frequent are these changes.
Yep.
And once we surpass those thresholds, we can say, oh, now we have something interesting. Like we have 50 people at the same time doing changes.
Yep.
And I would love to run that algorithm on a stream of data just to get real-time results.
Yeah, that'd be really interesting. I can even imagine using that for monitoring of your own application, like trying to understand, like the same thing you can do monitoring on Google Cloud Platform over logs and see like, oh, maybe the traffic is too high, send me an alarm.
Yeah.
Like you could do something more advanced.
Like business metrics. Like
business
how
metrics.
much money is being sold, like being spent and how many products are being sold. So that sort of stuff.
So with Dataflow, you have the ability to define some rules over some windows, sessions, time. And it makes it very, very easy to start defining that kind of processes.
Now I want to play with Dataflow more.
Oh, yes.
Dataflow is actually the only reason why I've written Java lately. Yeah, which, it's gonna, that's a big statement for me.
We also announced Python Dataflow.
Yeah, I heard about that.
But still not there. So
Okay.
Write Java in the meantime.
Okay, so we've discussed two things, BigQuery and Cloud Dataflow. I know, and now that you mentioned Python, you made me think about it. It's the Cloud Data Lab, yes. Yeah, depending who you are.
Depending on which accent in the room you're going to go with.
Yeah. By the way, accent-wise today, we've
almost got a whole... We haven't got quite a whole set, but we're getting close.
Yeah, we're pretty good.
I didn't tell people where I come from, but I'll let them guess.
Oh, yeah, that's...
There we go.
Use big data analysis to guess where Felipe is from. Tell us about Cloud Data Lab.
Yes, so if you have used the IPython notebooks,
I've done that.
Yeah, they're cool.
Yes, and you should call them now the Jupyter notebooks.
Okay, I will.
Okay.
Yeah, that's the
that's
their actual name now.
That's
Okay,
Okay.
cool. Okay.
Yeah, IPython split this project between IPython and the notebook, and now it's the Jupyter notebook because they support many more languages. It's not Python specific
Oh,
anymore.
cool.
Ah, nice.
Yes.
Okay, I didn't know that.
Did not know that either.
So the Jupyter names come from Julia, Python, and R.
That would make sense.
Yeah.
Something like that.
Yeah.
Cool.
Yes.
Okay.
So if you take those notebooks, I love them. They're a great way for data scientists to work with code, data, etc. If you take those notebooks, how can we make them package them as a service? How could we have a service that immediately deploys a notebook for you, takes care of storage, of storing them on a repository, it takes care of authentication with the different Google services.
Nice.
Basically, that's Google Cloud Data Lab. It's an easy way to deploy, manage, and work with Google Service inside a Jupyter notebook.
So if I'm like, I have all this data, I want to integrate it with some of our big data tools, but I want to like work in like say a Python environment or an R environment and something like that, and then get like maybe nice visualizations and that sort of thing. That's a pretty good environment for that.
Yes,
Perfect.
a pretty cool interactive environment. And yeah, you could do the same at home with your Jupyter notebooks, but then you need to take care of everything, installing them, authentication between your computer and a server. With this, they are just running there.
It's just easy.
Yeah, I love them.
That sounds really powerful, especially for education and things like that, where basically you want to teach someone statistics and you have data. It's like you can share it. That sounds really interesting.
Yeah, it's one of the best ways we have now to tell people this is how you can work with data at Google. There are some very interesting notebooks, for example, for working with genomics.
Oh, interesting.
We have a lot of genomics data in Bigquery. And the genomics team has published very cool data lab notebooks.
That's really cool. Especially what I like is that basically it allows you to do processing on what people are already used to. Like many people that do data science, they use Python. Mm-hmm. And they used to use IPython, now they use Jupyter. Yeah. So basically having the possibility of doing the same thing, but being powered by the cloud and having access to... Do you have also access to BigQuery?
Yeah.
Okay, so you have access to BigQuery. Do you have access... Not to Cloud Dataflow, because that's a different technology. That's completely different.
But what about Python Dataflow?
Oh, interesting. So can you actually combine all of those things on one single Jupyter sheet
thing?
You should be able to.
Okay.
We're moving forwards to getting that.
Cool. Just a little announcement. Well, not really an announcement, but the Cloud Data Lab is still in beta. So if people want to play with it, go see it and give your feedback. Like when you give feedback about beta product is when your feedback is gonna be really taken into account. So if you have strong opinions about the product, let us know.
Yes, please try it out. Most of it is open source, so you can find it on GitHub. You can file feature requests. You can send patches if you follow the whole how to contribute code to Google steps.
Nice.
That's very cool. No, I'm looking here. Apparently, we currently support, Python, SQL, and JavaScript for BigQuery user-defined functions.
Yes.
Cool. But it's also like pay for the resources you use. So you could fire this up and then run with it and then shut it down.
Yeah.
That's pretty cool. Nice.
No, that's really nice. Cool. So, okay. So far we've seen then Cloud Dataflow, Cloud Data Lab, and BigQuery. Is there any other products that you think we should mention? I mean, we also mentioned PubSub quite quick, right? Is there anything else that you would like to mention about?
It's just fun to see so many different names that people have to remember.
Yeah, they will all be in the show notes.
Yeah.
Yes. Usually when I say BigQuery, people remember Bigtable for some reason.
Oh, should we talk about Bigtable?
We should mention Bigtable. Bigtable is awesome. Bigtable is also another technology that from the beginnings of Google, we publish a paper. The world took those papers. They produce open source software based on it, like HDFS and Cassandra. And then many years later, we are offering Bigtable as a service.
Nice.
And it's HDFS compatible.
Yeah, that's really cool. I mean, I think that anyone that has been working at Google as a software engineer, like one of the things that you get to do is you get to write stuff on Bigtable. It's such an amazing thing to have that I'm actually really excited to be able to use it from the outside now. Like you can basically write your own project that uses Bigtable. That's gonna be really nice.
Yes. Not to be confused with Bigquery.
Yeah, so
different products.
Yeah, so we have 2 bigs and 2 data. So we have Bigquery and Big Data, Data Lab and Dataflow.
I think you mean Bigquery and Bigtable.
Oh yeah. Oh, that's sad. Bigquery, Bigtable, Dataflow, and
Data Lab.
Data Lab. There you go. Complicated.
At least none of these names sound like Pokemon.
Yeah, that's
There you go.
That's good. Great. So let's talk not anymore about tools. Like the tools, I think we pretty much done.
Mm-hmm.
I'd like to talk a little bit about what cool things you've seen with big data. Like what cool data sets or what cool projects you've heard about.
Okay, the coolest one for me, it's not many people can do things with it, but just knowing that people are doing genomics stuff with BigQuery, solving genomics problems with SQL.
I've actually seen a video of you analyzing your own genome.
So you saw a tweet.
Yeah.
So what's
what's genomics? I assume it has obviously something to do with DNA.
Yeah. So my favorite story here is when I met Jacqueline Collar, one of our sales engineers.
Yep.
She had joined Google like 3 months previous, and we went to the same event. We said hi. She told me that she already knew me, because when she was interviewing to work at Google, she had been watching my videos.
Okay.
And she used one of those videos to prepare a presentation for her Google interview, and that's how she got hired. So that was cool.
Yep.
Now, I felt it was a little unfair because she already knew me and I knew nothing about her. So we started talking. Then she told me about how she loves genomics, how she got her own 23andMe reads.
Mm-hmm.
So now she had her own genome sequenced.
Yep.
23andMe does only a small portion of it, but still, it's super cool. And she had already loaded it into BigQuery.
Okay.
So I asked her, well, have you analyzed it? Have you done anything with it? She was like, not yet. And I asked her, do you want to? Because I already knew what kind of queries we could run on her genes.
That's a whole new meaning to getting to know someone.
Yeah, no kidding.
That's cool.
Exactly.
So what sort of queries can you run?
So half an hour, it's like half an hour later after meeting her, I was analyzing her genes. And the basic...
No, you don't have to say the answers, but I mean, yeah. Like...
Yeah, so there are open databases of what each gene, what each thing read means.
Mm-hmm.
So you can start running joins. Hey, let's take your special
specific genes.
Yeah.
Yes.
Yeah.
Let's join it with this other table that says what each means.
Yep.
Let's start looking at, well, who are you?
Who are you? So we could be like, all right, let's take my genes, let's look Francesc genes and see if we somehow have a common ancestor.
You probably have a common ancestor.
Yeah, a long time ago.
It's possible. It could happen. I don't know.
Or maybe nothing common. Yeah, no, but you can see things like, you know that there are people that cannot tolerate eating cilantro.
Oh, yeah.
I'm one of those, yeah.
And that's a genetic thing?
Yeah, that's genetic.
And you can see it on
Okay.
We can find, yeah.
That's really awesome.
We can use BigQuery to find out if the probability of you liking cilantro.
Now I want to play with that. That's really awesome.
Can you twist your tongue? That's also codified in your
and
genes.
basically that's like, if you didn't do it with BigQuery, like that could be a decent amount of data. Like, I don't know if it's big data, but it's big.
It's a lot. It's a lot.
Yeah, so yeah, it could take quite a long time. How long could it take to run, like, to run one query that could tell you if I like cilantro or not.
With Bigquery, it takes seconds. It's
Really?
really
Nice.
fast.
That's cool.
I had the ability to sit down with her.
And tell her if she likes cilantro.
And so now you know her really well.
Well, kind of, in a way. But yeah, so I had to tweet about this. I
that was
wrote a
very
tweet.
nice.
That's the one.
Yeah,
that you
that's the
saw.
one I remember.
And then William Van Benepe, our product manager, replied to that tweet. And his tweet was, "Hey, I just met you, and this is crazy. But here are my jeans, so sequel them maybe."
Oh, wow. Maybe I should ask you to sing that, but no, let's not do that. Great. Any other cool big data set that you would like to
There's
mention?
so much public data, open data available now. This year I've enjoyed playing with taxi data, all the taxi trips in New York and visualizing what happens inside a city. Or also social media sites, having the full story of all the 1.9 billion Reddit comments.
That's a lot of data.
They were collected by users stuck in the matrix on Reddit, and then he published them, the comments. I took them, and now they are in Bigquery, so now we can analyze.
So are they a public data set?
Yeah.
Like anyone can just go and start play with that?
Yes, right now.
Great.
Just load Bigquery app, use your free monthly terabyte of analysis, and just start running queries.
1 free terabyte
Yes.
with a T. Wow.
With a
That's a
T.
lot of data.
That's that's big data. Okay. Oh,
And
that
that's free,
sounds
no
awesome.
credit card needed. Anyone can go and play with these data sets.
Okay.
Also, Hacker News if you want to see the difference, or GitHub. Or
Okay, we'll put a link to that on the show notes. That sounds
definitely
really fun.
Are there any other places you recommend if people want to go like looking for big data, open set data? Or is that giving away your special source of where you find this stuff?
I personally love Reddit.
Yep.
I even started one subreddit /r/Bigquery.
Yep.
So all the open data sets that I know of, that I've been playing with, any stories I know related with Bigquery, I put it there.
Perfect.
So go see everything I know at Reddit /r/Bigquery.
BigQuery.
Okay.
Awesome.
Wonderful. Well, is there anything else that we haven't covered that you want to necessarily throw in there about big data or BigQuery or Dataflow?
I guess you will need to have me again here.
I'm sure we can do that at some point.
I guess so. Well, thank you so much for being here, and talk to you soon.
Thank you.
Adios.
Thank you very much to Felipe for joining us for this interview today. I found that particularly interesting. I don't do a huge amount of big data stuff, so that was really great hearing about all the products and all the things that he's been working on.
Yeah, that was lots of fun.
Lots of fun. But we have a really interesting question of the week yet again. Started with a conversation I had with Andrew Watson. He was talking about sort of environment variables in App Engine, and it sort of expanded from there into sort of, I've got like a password or a credential or a secret key. You know, I need to store that somewhere safe within Google Cloud Platform and be able to share that with a variety of services. What sort of the ways I can do that, or maybe even just what's the best way of doing that? Now, I know you've got some opinions on this, Francesc.
I do have some opinions.
Yeah.
So it really depends on what you're actually doing. So
Yep.
I know that, for instance, if you're an App Engine,
Yep.
there's App Engine environment variables.
That's true.
That works very well. But it will be available only for App Engine.
Yep.
If you're in Kubernetes,
Like secrets?
There's Kubernetes secrets.
Yep.
So that's a very good solution when you are running everything in Kubernetes. But by default, my go-to way of storing stuff, secrets, but not only secrets, also configuration and
Yep.
all of those things that you want to share across all the agents of your system,
Yep.
is the metadata service.
Ooh, that sounds interesting. Tell
Yeah.
me more about what that is.
So it's something really simple. It's basically a way to store metadata.
Like
And
key
then
value pairs.
Key value
Yeah.
pairs, exactly. So you have a key, which is a string, and then a value, which is a string. That's it.
Cool.
And the good thing about it is that it's actually very safe.
Okay.
It's very simple to use. It has a REST API, and it uses authentication.
Yep.
So you're gonna need some scopes to access it and everything. But if you're doing it from inside of Compute Engine, by default you're already authorized to do it.
That's nice.
You're actually gonna be hitting an internal endpoint.
Yep.
So even just curl will work for you. If you're doing it from outside of Compute Engine, you will need to use the REST API that then allows you to access the same API, but with authentication.
Oh, that's really cool. So I only thought you could access the metadata stuff basically from within Google Compute Engine, but you're saying like we can actually access that from anywhere.
I did that too. I did think so too. Yeah. And actually, while preparing this podcast, one of our colleagues, Sandeep, showed us that we were wrong, which is awesome.
That's great. I love being wrong.
It actually makes your life much easier. Basically, you just keep all your data in the Compute Engine metadata service.
Yep.
And you can access it from wherever you want.
That's really, really handy. You can just add whatever you want in there, and you just need to know it's secure. It's encrypted both ways and unstorage too.
It's incredibly simple. Yeah, it's encrypted not only at rest. So once we store it encrypted, but also in transit. So while it's going from the service to your instance, it will also be encrypted there. So it's really, really simple to use. If you had other things that you wanted to share, like they were like, imagine it's not just something quite small. It's like, I don't know, a big file or something that you want to keep secret, then probably Google Cloud Storage is just the best way to do it, because then you don't have limitations on the size. You can keep whatever you want, and it's also very secure. It's encrypted. It's going to require you authentication of the same things, just bigger.
By the same token, I suppose you could also use Data Store or even Cloud SQL if you really wanted to.
Yeah.
Yeah. But it sounds like the metadata API, I mean, that sounds like it's kind of built for this stuff. It sounds like a really good solution.
It's the simplest way to do it. And yeah, I guess that one of the cool things of this is that, it also works outside of Compute Engine. So you can access it through REST APIs.
That is very, very cool.
Yeah.
Awesome. Well, this is the last episode of the year. It's a shed a little of a tear moment. I'm a little bit sad.
Sadness invades me.
Yeah, I'm going to miss you for the next few weeks, but we're definitely coming back in 2016.
Yeah, we're coming back the beginning of next year for more and better.
More and better. We've got a very exciting interview lined up, but I don't want to say what it is.
We're going to keep it secret, but I think it's going to be really awesome. It's about something that I really like.
Yep.
So, and
it's not Go. It's not Go.
It's not about Go.
It's not about Go.
Okay, it's not about Go. Maybe we should do something about Go too. But it's going to be really interesting, and with someone that really knows what he's talking about. So I'm very excited about this.
Sounds good. So definitely, people, check in with us in 2016.
Yeah. So let's see you soon in 2 weeks. See you all soon. We've finished now with our 8th episode.
Yep.
And hoping for many more to come next year.
Definitely. We'll see you next year.
See ya.
Bye.
Hey, I just met you, and this is crazy, but here's my DNA, so sick of me maybe. Woo!